Like 15. What'd you get? Yeah, for 22 and 23, they were really small.
Yeah, I think it's like
All right, so you're tossing a coin 20 times, and you want to get the number of heads. You want to get 11 of them. So you want to find the probability of the success then, where k is going to equal 11. Do we agree on that?
Yeah.
So when you substitute all this in, you're going to have 20. We're going to choose 11. And then it's probability of success with 0.5 to the 11th, and then 0.5 to the 9th.
That's exactly what I did. Oh, I did one.
Wait to the 9th. Oh, this is.
Because what's the probability of heads and tails? It's just 50%. So. Did you put 0.55?
Yeah.
There's your problem.
I don't know why.
Okay. Now, with the other ones, Michael, do you have a question on that?
Oh, no,
Michael, I got a whole bunch of scratch paper in the back there by the little 3-cent thing. It might have formula sheets or something, but one side doesn't have something on it. It's up shelf. And there's a whole pile of junk. In that whole pile area vicinity, there should be like somewhat half of a sheet of paper. You're welcome. Probability randomly guessing to get a random thingamajiggy with the stuff and the things and the whatever. What number of these did you have to do? Do you letters?
23, 22, and 25.
22 and 23? Oops. Well, let's do 23. So your probability of success here is going to be 20.
Oh, shoot, I did the wrong one.
I did 23. I did 23 here. How many questions are on the test? 30 of them. So you're going to have 30, choose 20, and then what's the probability of success? What's the p-value? 0.25. Good. Not 0.255. To the 20th. And then did you do 0.25?
No, I didn't.
And then what is the probability of failure then? Or 1 minus p, excuse me?
2.
And this has to go to the 10th.
No, I'm joking. I got the right answer.
Okay. It's okay. Here, you can have an air hug because we all love you.
No.
This is an air hug. Because everybody give her an air hug, make her feel better about life. Everybody give air hug.
No, I don't like it. I don't like physical contact. I really don't.
Well, it's a good thing it's in air. And
Yeah,
you have to pat.
like, you still
Patting
have the
makes it
idea.
sarcastic.
Just the, I hate it.
Now, the other parts I want to look at real quick here is how do you calculate something like this?
I hate it. It's just awful. I can't hug my family. No, like my families.
What I want to do here is look at this. The next step in this is we kind of did a little bit of this yesterday, where we're going to calculate the probability of successes, or the probability of successes that are greater or equal to 3 for 5 total trials. So that means I have to add up the probabilities between what numbers? 3, 4, and 5. So what we're going to wind up doing here is when they have a question like this for k values that are greater or equal to 3, you're going to do the probability of k equaling 3, probability k equaling 4, probability of k equaling 5, and just add all those together. Does that make sense? Michael, you look at me like I'm really, really nuts. Whoa! Now I'm really nuts. Have we met?
Where'd you get the formula?
What's greater than 3 but not equal to 5?
Yeah.
That was not an awkward laugh. So you have 5, choose 3. They're telling you the p-value is 0.2. To the third, what would be 1 minus p? 0.8. To the second, 5, choose 4. 0.2 to the 4. 0.8 to the 1. 5, choose 5. 0.2 to the 5th. 0.8 to the 0. And you just add those 3 values together. Does that make sense? Yeah. Like I was saying, guys, binomial probability, it is not a complicated process. It's just a lot of button pushing. Okay. So I'm hoping that It's actually kind of cool because this is the kind of stuff that you can use to your advantage for multiple guest tests. You know, think of your final. We were just talking about this. Mr. Fontana, Ms. Denny, and I were talking about what's the probability of taking your final and not having any B's on it. You know how you guys go through you go through 50 questions and all of a sudden you're like, oh man, I haven't had a B in a while. Have you ever done that on a multiple choice test? Yes.
Yeah.
Or has any of your teachers ever done that just made all the answers B?
Not all of them, but like Mr. Shadow always has like 4 in a row.
And we're like,
Because it makes you second guess. I think that's awesome. I would do something like AC/DC each time because it rocks.
Or like where you go like this.
Yeah, make little patterns.
I love it.
That'd be kind of fun.
I'm
But
actually down to the answer.
it's you think about it. You can do binomial to do that, or you can actually use a complement. What's the probability of every? Let me ask you this: if it's a 50-question multiple choice test, what's the probability that every question answer is B? Well, 25% it is B, but how many questions are there then? So it would be 0.25 to the 50th power. That's the probability of everything being B. So if it's not B, it would just be the complement of that. 1 minus. It's kind of cool. So, all right, I like statistics and probability. I think they're kind of cool. There's just, like I've said many times, 80% of statistics are made up on the spot, and they're half right.
I get it.
Baby, you're awesome.
I know.
And modest. Real fast then, I'll just do this last one and call it a day. Let you guys do some problems. In a particular court case, the legal analysts, determined from the evidence presented that there is about a 90% probability a jury will vote the defendant guilty. Find the probability that all jurors will vote the defendant guilty. So, how many trials are there? 12.
12.
Because you're going to try all 12 people. How many successes do you want to get?
12.
12. You want to find the probability that the K value is going to equal 12 for all N people. You want everybody to vote guilty. What's the probability of an individual voting guilty?
9.9.
0.9. So this is going to be 12. Choose how many?
12.
0.9 to the what power?
12.
And then
1 to the 0.
pretty easy, isn't it? Remember, the 0.1 comes from the 1 minus P value. That's the secondary part there, okay? Those are the two parts you work with. You get the original probability, 1 minus it is the second part. So you start thinking about it. If they say there's a 90% chance the jury's going to vote somebody guilty, the percentage when it breaks down to, when you're asking everybody, it's only a 28% chance that all 12 of them are going to vote guilty. Remember yesterday we talked about that question about UFOs, and we were really, I think your class was what, 40%?
Yeah.
Is 40% of you guys believe in UFOs, but the book said 37% would happen? This was crazy. The second class, 6-7, when they voted, the percentage dropped. The overall percentage between two sections dropped to 37.5%. So it was almost there. 12th hour came around, and I'm not kidding you, we wound up at 37%, exactly what the book said. And then I had 6 people here, chose the 6, 2 of them believed. I had 6 people in the other class, 2 of them believed. So it was just kind of worked out in my favor that the numbers that I was picking were.
I think it's a bad
I got really lucky, okay?
Because believing in believing in UFOs isn't the same as believing in aliens.
I didn't know that.
Yeah.
I agree, because sometimes
I mean, because if an alien were to come to the world,
UFOs.
I feel like if they had the technology to get here,
Do you think they'll let me?
they would be craftier
they have a cloaking device like Wonder Woman.
They'd be craftier than just hovering over the earth.
Like Wonder Woman flying an airplane. Nobody notices some girl in the air walk around.
I guess the thing with
is more like a UFO could be something completely
Right.
different than what everyone believes
Right.
to be an alien spaceship.
I-
Could
I-
be something else.
I'm
And
completely
that's
with you on this.
what everyone believes it would be, something alien, not
People
something
lose.
human.
What would you be?
Thank you.
Can I just put this on the same?
Yeah, just add to this.
Sorry, I read that very good.
You know what?
Such a waste of paper. You're encouraging the killing of trees.
Do a draw.
Shame on you.
Actually, mine.
Don't draw. Oh, don't draw. Okay.
Don't draw the histogram.
Sweet.
Can I just add it on to like today?
Yeah, absolutely. Just put it on what you had going on there. It's the same stuff, same page. It's just gonna. There's a couple of word problems on there. Like when I said, like 37 through 41. If you look at it, like 38 it says draw the histogram. Don't do that. Just go right to 39. You know what I mean? So you do 37, 39. I think it's 41. No, because you can look at it in your calculator. There really isn't, because I want you to be able to look at the histogram, and that's why I showed you guys how to do that, because we're going to use the histograms to start to draw the normal curve next week. Exciting.
My friends